Welcome back, everybody. This is Chapter 10. This will be Part 4 of our discussion on gases. And we continue our discussion of the simple gas laws, and this time we're going to be discussing Avogadro's Law. Avogadro's Law states that volume and moles have a direct relationship. So that is that if you increase one, you increase the other. And so this one is similar when you do calculations to Charles' law, which is temperature and volume. So V1 over N1 equals V2 over N2. So that's how this one works, okay? Equal volumes of gases contain the equal number of molecules. It doesn't matter what gas it is. So gases are a little bit different from what we've seen when we were talking about solids and things like that. So since the volume is directly proportional to the number of molecules, if you increase the number of gas molecules, more of them are going to hit the wall at the same time. If you keep the pressure constant, then the volume has to increase. All right. So an example of Avogadro is a male athlete in kinesiology research study has a lung volume of 6.15 liters. So we have a volume of 6.15 liters during his deep inhalation. At this volume, his lung contains 0.254 moles of air. And remember, air is a mixture of different things. And during exhalation, his lung volume decreases. So we got a new volume. So these were ones. So the new volume is 2.55 liters. And it wants to know how many moles of gas does he exhale. And I emphasize that because it doesn't say how much does he have left in there. It asks you how much he exhaled. So we're gonna put this in, and remember, we know the relationship, but whatever we're looking for, we try to make sure that that's on the top. So I'm going to rewrite this to N1 over V1 equals N2 over V2, and we're solving for N2. So N2 equals N1 over V1 times V2. Okay? All right, so N2 is equal to, now I've got liters and I got moles, so I'm set. So I have N1, which is 0.254 moles, times V2. And always you got to check, make sure you're doing the right one, because that's the most often mistake made, is to flip those and put the wrong one there. And then we're going to have V1 on the bottom, 6.15 liters. Liters will cancel, and I'll be left with moles. And then all I have to do is plug and play into my little handy dandy calculator, and I should get 0.105. Now, think about what this is. Okay, this is how many moles are left in the lungs. Okay, so but it's asking me how many moles he exhaled. So in order to find that, I have to say that I had 0.254 during inhalation, and I had 0.105 left after exhalation. So the difference between those two is 0.149 moles. That's how much he exhaled. So that one was a little tricky. You had to really read how the words were in that problem to make sure that you were calculating the right thing. So it's just one more step. So if you'd gotten this right and given it to me, maybe you would get half for that problem, right? So make sure that you read and know exactly what it's asking you for. And there's your practice for Avogadro. The combined gas law, since we've talked about pressure, volume, temperature, and number of moles, I just want to show you that with all these relationships, I can combine them all into what we call the combined gas law. And so P1V1 over N1T1 equals P2V2 over N2T2. And I had a professor way back when I first started this taught me that pigs vomit over nasty troughs, and that's how I remember this formula to this day. And it's a really cool formula because if you remember pigs vomit over nasty troughs, then you can always know how to calculate something. If you're given just volume and temperature, then you can just look at volume and temperature. If you're given temperature and moles, you can do that. So you can use this formula to remember how all of the other ones work. Okay, but anyway, that was Avogadro's law, and then I was introducing you to the combined gas law, where you put Boyle's, Charles, and Avogadro all together to combine them into the combined gas law.